So, this presentation concerns the demonstration of the HERON Decision Support Tool. The structure of the presentation starts with the problem, then continues with the concept, the approach that we followed in order to translate this concept in concrete steps, and how this approach led to the methodology of the Decision Support Tool. We will show you what is finally the HERON Decision Support Tool, the software, and very last we will tell you a few conclusions about its use. The problem started when we were writing the proposal of the HERON project, and we understand at that time that the problem was how to reduce the observed deviation in the energy efficiency targets and attributing this deviation to the end user's behavioral barriers. It was a discussion of that time that the European Union was going to miss its targets about the 20% in energy savings up to year 2020, and there were discussions on how these deviations could be reduced, could be handled, and how to proceed in such methods about it. There was also an additional problem about how to improve the energy models of that time and how to incorporate real characteristics into them, such as the human behavior. The concept, in order to solve this problem, was to quantify the available qualitative information that concerned the end user's behavioral barriers and to make it part of the energy efficiency modeling. Our approach, in order to materialize this concept, was these four actions. One, to calculate the occurring deviation by using the impact factors of barriers. By impact factors, we mean the negative contribution that barriers have in order to achieve the final energy efficiency target, and these were used, the impact factors, not only for the final energy efficiency target, but also to be connected with the input drivers, technologies, policy instruments. The next action that we saw that needed to be as part in this approach was to have the optimization process. This meant that we had to select the optimum combination of the input drivers and to be able additionally to reduce the impact factors of the barriers. These two optimization processes allowed us to develop a set of optimized scenarios. And because of this set, we could have a variation of the options that the user could have, develop their scenarios, and from those scenarios to conclude with the most preferable one. The methodology is 6 steps. 4 of them are based on the analytical hierarchy process. You can see them here, but more details can be found in the manual, which is available on our website of the project. So I'll go through them very quickly. In step 1, we have the mapping, categorization, and if necessary, the merging of the behavior barriers, because some had the same name and had to be replaced with only one representing everything. Then we developed, based on step 1, the AHP tree and its matrices. We calculated, following the AHP procedures, the weight coefficients, and based on this step, we were able to define and calculate the impact factors of the barriers. Then we linked these impact factors with the input drivers, the technologies that are used in our scenarios, and we incorporated the total impact factors in our model. In order to explain a little bit more, we have this AHP tree. We have the first level, the 0 level, where the goal is, if we are using barriers, to limit the efforts for achieving the energy efficiency target. Then we have the second level, where we have the 3 main groups of the barriers: social, cultural, educational, economic, institutional. The next level is a deviation of the first main group into social, cultural, and educational. And finally, we have the set of our barriers. We have this number of 27 barriers, each set for one of the sectors that we examined 27 for the buildings, and 27 for the transport sector. You can see here for the building sector, our first group, you can see the type of the subgroup, social, cultural, educational, the name of the barrier, and here we have the function that allowed us to calculate the impact factor. The impact factor is from multiplying the weight coefficient of the main group, of the subgroup, and of the barrier itself. Then we have for the other two groups, you can see here again the names and the calculation of the impact factors. And then, as we said, steps 5 and 6 concern the total impact factors and how these are incorporated in the energy efficiency modeling. We calculated the total impact factor by linking each driver with its relevant barriers, the barriers that are responsible for not being for not proceeding with its penetration if it's a technology, for not achieving the specific target, and we summed up these impact factors and had finally calculated the total impact. Then we proceeded with the calculation of the deviations, where you can see that the new percentage is calculated by using the one without barriers and incorporating the total impact barriers of one input driver if the technology is only one, or of a set of technologies or input drivers as we name them. For the procedure that concerns the optimization, we calculate the reduced impact factors. So we have the new impact factor of the barrier in year T after using this equation. We use the time interval for 15 years. If we use the time interval of 2015 to 2030. And we used a reduction share of 20% after these 15 years according to UNEP. Now, all this allowed us to develop the software. And let me show you the software. This is our first screen where you can see a flow diagram that explains the procedures that are taking place. And this is our first basic screen. You can see here that we have in the rows and in the columns the same names that concern the three main groups of the barriers. And here we will compare them between them. So when we compare social, cultural, education with itself, it's 1 because they are equal. If we need now to compare the first main group with the second one, we need to take into consideration conditions that allow us better to have a clear opinion of which is more important compared to the other. Once we do that, we will set a number in this cell from this scale. If we're not sure what these numbers represent, the software has here the information about the scale, so we can choose whatever suits us better in order to represent the importance that one main group has over the other. Once we select this, we set it and it's placed and two cells are filled at the same time. If we select here another one, then that goes here. Here for the third one, and then we are able to calculate the weight coefficients. The results are tested in order to be sure about its consistency, that everything is acceptable and that we can proceed. We accept and we are able to go to the next level. In order to save time, we have already prepared such a file, and everything now is filled. I'll show you one of these, so you can see that even these larger matrices are filled. We have the calculated weight coefficients and the results are also accepted. Once all the tables are filled, we can incorporate the impact barriers into the targets. So we have here the second main screen where the user can select according to his or her preferences. We select the country, the sector is the building, and the general target is set. We can set any energy efficiency target that we want. You can see the several options that are here. We will type 20, meaning that this is 20% reduction of energy consumption, and we can select the technology that will support this scenario for us. I'll select from these technologies these ones, and we calculate and see the outcome. We can also see the deviation, meaning that we target a reduction of 20%, but now, due to the barriers, we only achieve 3.7, which shows that there is a deviation of almost 16%. We can minimize this deviation by selecting the barriers that we consider that can be confronted with the appropriate policy mixture. So I'm selecting some of these barriers that will be part of our scenario with the respective policy mixture, and select for a time interval of 15 years. We minimize, and we can see now that the deviation is lower, and we have 5.1 compared to 3.7. But the best, let's say, thing here is that if the user does not know which combination of technologies to use, the software has the option to select. So if we select these, you can see now that the deviation is much less, meaning that with this set of technologies we can have better results. Again, we can minimize, selecting the barriers that we consider that can be confronted, the same time interval, and you can see that we have much better results and much less deviation. If the user does not want to set a general target but to use specific technologies, there is option to select also. So I'll select here 3 technologies and provide here the percentages that correspond to what a user may select. 45% penetration of efficient heating, 37 for the efficient cooling, and let's suppose that it's 20% reduction in energy consumption. Calculation, and the user can see how these percentages are modified because of the barriers. Now, if the user wants to minimize and selects that the priority technology out of these 3 is the building cell improvement, it can open this one, and the user can minimize barriers that affect the other 2 technologies as well. So by selecting here high cost, lack of data, lack of experience, problematic network, and so on, assuming that the respective policy instruments will be part of the scenario, here are the new percentages. So someone can see that they are improved. From 30% in efficient heating, we have 35. From 29, almost 30 in energy cooling, we have 33.5. And for building cell improvement, from 4, we have increased to 7. So this is how another scenario by reducing the impact of barriers can be formed. Instead of selecting these 3 randomly arbitrary, the user can select the best combination. So if the user wants to see what's the best combination of 3, it can see for the case that we have selected that it's building cell improvement, efficient cooling, but not energy heating, efficient appliances. So by selecting this combination and placing again 20%, penetration of 35, and appliances, for instance, 20%, or 47 as it was for the heating. We calculate, we see the percentages, and then we can minimize again. We select the common ones. The priority technology is again the building self-improvement. I try to select the same barriers as previously. And minimization. Now you can see that we have almost 7 as previously, but now we increased in cooling a little bit more, and in appliances we reached 36.7. So after doing that, the user has the option to have all these outcomes. So if I select to get them, and I write the name of the file, everything is saved. I can open it and see them. So I can see the weight coefficients, meaning the outcomes of the first main screen of the software. I roll down and I can see the set percentages that I had initially. Then the barriers that I minimized and the new percentages, and the percentages that I had per technology. As you can see, I have appliances, the last one that I had, and here are the outcomes. So this is how it works. And back to our conclusions. So the software can allow us to have common sets of barriers. Of course, each country and each user may evaluate differently the impact of barriers. It depends on the information that he or she has. We can see the deviations from the energy efficiency targets and the options that a user can make in order to reduce them according to the preferences per each examined case. The outcomes can be saved in an Excel file, and these from the Excel can be incorporated in the energy modeling. And of course, this is the basis for research in a new area. Thank you very much for listening.